Hello everyone. Welcome to my YouTube channel Psychology Class for All. Today I will discuss quartile deviation in psychology, a smarter way to understand the score spread. You know the average score, but what about how far students typically stray from the middle? That's where quartile deviation shines. A perfect tool to explore psychological data without getting tricked by its outliers. So, what is quartile deviation? Quartile deviation, also known as semi-interquartile range, and it is half the difference between the third quartile and the first quartile. So, formula is QD is equal to Q3 minus Q1 divided by 2. It shows how spread out the middle 50% of the data is, making it more robust than the full range. Let's understand it with a visual help. Here is a box plot that highlights Q1, that is the 25th percentile with a green dashed lines. Q3, the 75th percentile with the orange dashed line. The shadow yellow region shows the interquartile range, which is used to calculate the quartile deviation, that is Q3 minus Q1 divided by 2. So this visualization helps in explaining how QD focuses on the central 50% of the data while ignoring extreme values. Now, how to calculate QD from ungrouped data? Let's take an example of psychology test scores as 5, 7, 8, 9, 10, 12, 14, 15 and 18. First of all, arrange the data in an order that is already arranged over here. Find Q1, that is 25th percentile, and that is median of the lower half, that is 8. Find Q3, 75th percentile, median of the upper half, that is 14. As you can say, the median is, as you can see here, the median is 10 and the first quartile's median is 8, and then the second or the lower half median is 14. So QD is 14 minus 7 divided by 2, so 3.5. The middle 50% of the scores lie within 3.5 points of the median. It is displayed over here with a line graph with middle 50% IQR that is shaded. Here in this line graph of the data that shows the middle 50% IQR value shaded in yellow. The Q1, that is 25th percentile, that is 8, shown as a green dashed lines, and Q3, that is 75% percentile, that is 14th, shown in an orange dashed lines. This helps in understanding or highlighting the range of values contributing to the quartile deviation. Now, how to calculate QD from group data? There is a frequency distribution data, hypothetical distribution data from a stress score. Steps: first of all, you need to find Q1 position, that is total n divided by 4. Total n should be divided by 4. Here it is 24 divided by 4, that is 6. So Q1 lies in the class interval 10 to 20. Then apply the formula Q1, that is L plus N divided by 4 minus f divided by small f into I. Here, capital L stands for the lower limit of Q1 of the class interval, that is 10. Small f, that is the cumulative frequency before the class interval, that is 2. Capital F, it is the frequency of the class interval, that is 4. And I is the class width, that is 10. So, placing all values in the formula, that is Q1 is equal to 10 plus 6 minus 2 divided by 4 into 10. It goes like 10 plus 10 is equal to 20. So, Q1 is 20. Now, repeating the same for Q3. Using the formula, repeating the same thing for finding out the Q3 using the formula 3 into n divided by 4, that is 18, which lies in the class 30 to 40, class interval 30 to 40. Now Q3, the formula for Q3 is 3 into L plus 3 into n by 4 minus capital F divided by small f into I. Now here the values for each character represented in the formula is lower limit of Q3 class is 30, cumulative frequency is 14, frequency is 6, and class interval is 10. So placing all the values against the formula, the outcome is 10. QD is equal to 10. Now depicting this with the example of a histogram. Histogram with cumulative frequency and quartiles. Here is the that arrows pointing to Q1 is equal to 15, that is 25th percentile, and Q3 that shows the 36.67, that is 75th percentile. This cumulative frequency curve that is in red, that helps visualizing how data accumulates across stress levels, while the arrows and annotations clearly highlights the quartile spread. Why QD is important in psychology. Quartile deviation calculation is very much important because we know that human behavior is variable. QD helps to capture that without being fooled by extreme scores. It is useful for psychological skills like anxiety, stress, motivation, etc. QD is not affected by its outliers, unlike range or even standard deviation in its skewed data. In a motivation test, some highly unmotivated students score very low. I'm explaining with an example, but QD still gives a stable idea of middle group consistency. So where QD is used in psychology? It is used in non-parametric tests. It is used with Likert scale questionnaires. It is used for robust analysis of therapy outcomes. It's being used while assessing group consistency in research. Now there is a comparison table of quartile deviation with other measures. Other measures that we have already learned in the previous videos as range and interquartile range. Interquartile range, here I have depicted it as interquartile range versus QD. So quartile range is based on extremes where IQR and QD or QD is based on medians. Range is sensitive to outliers, but IQR and QD is not sensitive for outliers. Range is good for small data sets and IQR and QD is good for skewed or ordinal data. So, quartile deviation may seem small, but it's a powerful tool in psychology. If you are serious, if you are serious about psychological research or scoring high in your exams, go and master the QD. And don't forget to like, share, and subscribe. Thank you.